Ladies and gentlemen, welcome. This is video series 2, part 4. In part 3 of video series 1, I have shared with you some highlights on how the problems in quantum mechanics and quantum entanglement are solved with the new theory. In this part, I would like to share with you more details. As I explained in video series 1, physics experienced a golden time period in the beginning of the 20th century. You see many open and critical discussions. One well-known debate was on quantum mechanics. It was on whether quantum mechanics is real or not. The debate was centered on a phenomenon called quantum entanglement. Quantum entanglement means that information could be transferred at a speed that is higher than the speed of light. As you may know, one of the cornerstones of general relativity is that the highest speed in the universe is the speed of light. The essence of the debate, therefore, is whether quantum mechanics is wrong or general relativity is wrong. There were two camps. One camp was led by Bohr, who defended quantum mechanics. Another camp was led by Einstein, who were against quantum mechanics. Since the general relativity had already got some experimental support, while quantum entanglement was only on paper, Einstein had the most support from the physics community. But Bohr didn't give up. The 1927 Solvay conference was remembered as the battle between Einstein and Bohr. You see on top a photo from the conference. When I looked back, I saw both Einstein and Bohr didn't realize that they are facing a fundamental philosophical problem, namely the time-related causality law of Aristotle. I would like to mention the role of Schrödinger in the debate. Schrödinger is the founder of the Schrödinger equation. The equation is the mathematical expression of the superposition law in quantum mechanics. But he was against the explanation of Bohr on the superposition law. He designed a few think experiments to prove that quantum mechanics is wrong. The most famous one is the cat experiment. See the drawer in the bottom. You can find many stories about this cat experiment. According to the new theory, this think experiment is wrong. Schrödinger wanted to demonstrate a non-time event, but he built a time sequence in it. See the circuit part on the drawing. I would like to mention that the wave-particle duality property was also a part of the debate on quantum mechanics. The certainty concept of Aristotle and Plato doesn't allow a thing to have such a property. This property even takes some people out of their comfort zone today. This certainty concept is removed in a new philosophy system. As I explained in video series 1, in a new philosophy system, the ceiling of Aristotle is removed. quantum mechanics becomes very easy to understand. In the new philosophy theory, quantum phenomena are governed directly by the laws in the new philosophy theory. They are a direct manifesto of the behaviors of the well box of a microsystem. They can be described directly by the changes in the shape and the position of the well box of an existence on a joint. It is also important to know that every physics law plays a role in the evolution of the universe. Quantum mechanics slow down the evolution of the universe because it is driven by the will of individual happiness of the universe. On the other side, general relativity speeds up the evolution of the universe. It is driven by the will of group efficiency of the universe. There are three basic things for quantum mechanics. They are the definition of a quantum system, the causality law, and the will conservation law. First, a quantum system is a microsystem. In part 2 of this video series, I have explained the definition of a microsystem. I repeated the definition of a microsystem here as the following. The wave change of the system is sufficiently small. The wave box of the system can oscillate. The individualism plays a dominant role in the system. Second, the time-related causality law. The time-related causality law means that if two related events happen over distance, the time interval between the two events should be longer than the time that light needs to travel over the distance. In a new philosophy system, if the relative disorder of the wave box of a system changes, the system needs to obey the time-related causality law, or an event in the system takes time. If the relative disorder of the wave box doesn't change, the system doesn't need to obey the time-related causality law, or you can say an event in the system happens instantly. Third, the new will conservation law. Its definition is that the total area of the wave box of an isolated system is a constant. An isolated system needs always to obey the will conservation law. Quantum mechanics describes the behavior of a microsystem. A microsystem has a very little group interaction component. The certainty concept of Aristotle and Plato is removed in the new philosophy system. The wave box of a microsystem is therefore at a constant oscillating state. There are two basic oscillating modes. In the first mode, the wave box is oscillating along the axis perpendicular to the axis of time. See on the top joint. The wave box is oscillating vertically. The time axis is horizontal. See in the bottom. The oscillation doesn't change the relative disorder of the microsystem. The microsystem doesn't need to obey the time-related causality law. An event in the system happens instantly. This mode is the base for wave-particle duality law and quantum entanglement. In the second oscillation mode, the wave box is oscillating along the axis of time. See the bottom drawing. The wave box is oscillating horizontally. The oscillation changes the relative disorder of the microsystem. The microsystem therefore needs to obey the time-related causality law. An event in the system takes time. This mode is the base for the Heisenberg Uncertainty principles. In a debate of 1920s on quantum mechanics, Bohr insisted that superposition law is the cornerstone of quantum mechanics, but he had difficulty to defend it. When I looked back, I see that the physicists at both camps of the debate had some difficulty to understand a simple principle that a macrosystem has a great degree of certainty, but a microsystem is full of uncertainty, especially for the outside observers. In the new theory, the superposition law reflects the oscillating property of the wave box of a microsystem, which is the intrinsic uncertainty property of the microsystem. The new theory can explain the uncertainty property of a microsystem. A microsystem is dominated by individualism. It has little or no will of group efficiency. This makes a microsystem almost fully free and uncertain. They are only constrained by the laws in the new philosophy series. The drawing describes the superposition law. The wave box of a microsystem is changing with a boundary with the red dashed line. The interaction of a microsystem with its environment moves its wave box downwards, increase its certainty. For instance, when a photon is absorbed by a detector, its certainty is increased. When a photon is emitted from an atom, the certainty of the atom is increased. In a new theory, quantum entanglement doesn't change the relation between disorder and order of a wave box. It doesn't need to obey the time-related causality law, or it happens instantly. When two entangled photons are produced from one photon, as shown on the top left drawing, the individualism of the wave box of the photosystem is enlarged. The new wave conservation law requires reduction in disorder and order of the wave box. The wave box of the photon system is changed from 2 to 1 on the drawing. The energy of the photon is reduced, its structure is weakened. The energy and the angular momentum conservation laws become invalid. When one of the two entangled photons is detected, as shown on the top right drawing, the individualism of the whale box of the photon system is reduced. The whale box of the photon system is changed from 1 to 2 on the drawing. The energy and the structure of the photon systems are restored, but now among two photons. The energy and the angular momentum conservation laws are restored. Information about these two photons are shared instantly among the two photons. As you can see from the drawing in the bottom, the Wheel conservation law governs the whole quantum entanglement process. For the two entangled photons, as shown between the green and the red bars, the quantum superposition law, the angular momentum conservation law, and the energy conservation law are invalid. In the new philosophic theory, quantum entanglement is not only limited to quantum mechanics. It is a universal phenomenon. For instance, it can happen in physics, biology, and in the original consciousness of a human being. The following conditions should be met for quantum entanglement. First, it is a microsystem or a microsystem attached to a macrosystem. Second, individualism is dominant in the microsystem or the system has little or no group interaction component. Third, the Wheel conservation law must be followed. When the individualism of the microsystem increases significantly, quantum entanglement starts. When the individualism of entangled microsystem decreases significantly, quantum entanglement ends. Also important, a physics signal transmission system is not allowed between the members of an entangled microsystem. Since a physics signal transmission system with a time sequence would force the microsystem to obey the time-related causality law. In an entangled microsystem, all entangled members share their information with each other. The last shared information is the information and at the moment of ending the entanglement. Since it's a microsystem, the amount of shared information is very limited. In part 4 of video series 1, I shared with you a few examples of the applications of the new philosophy theory for daily life. One of them is the explanation of two persons falling in love. Let me explain it in a little bit more detail. In the new theory, interaction between existence is driven by the interaction of their wills. Everyone has a unique, original comprehending capability when he or she is born. This capability is governed by the original will of individual happiness and the will of individual efficiency. When the will of individual happiness and the will of individual efficiency of one person into an oscillating state, this person starts loving or understanding something or someone. When the will of individual happiness and the will of individual efficiency of two persons into a same oscillating state, these two persons fall in love and understanding each other. When the oscillation of the wills of the two persons continues for some time, and their interactions could be then reduced, their will could become then entangled, resulted in a long-lasting love. With this example of the application of the new theory for daily life, I would like to close part 2 of video series 2. Thank you for your attention.